Record this. Okay, evening, everybody. Today we have open class for the analysis of solution for CCC 2025 S1 S4 to S4 problems. I assume most of you have taken this competition, right? So let's go to Danny. Danny is Jonas. Okay, so here the this I have already included a problem in the topics. So CCC new problems. Okay, and these are all the problems from 1996 to 2025. So today we are going to focus on the first four problems. First problem is called let's open it. This is called CCC 25 S1. Positioning Peter's paintings. Peter the painter just finished painting two rectangular paintings and would like to display both on a rectangular wall which has the smallest parameter possible. I'm not going to read everything, okay? I assume everybody knows it, and actually this is a very simple problem, right? If you understand it, the thing is, if you understand it, let me just I'm not going to read everything, okay? So the important thing is you need to know that is so must be upright. So this means no rotation, okay? No rotation. And also another one is it has to parallel to the floor. So that means so this is A and B, right? A is the base. A is here the base, okay? So this is A and this is B. And you have another painting, so which is X and Y, X and Y. And you have to use a rectangle to include all of them, and they cannot be overlapped. I think there is a restriction says no overlapping, right? So without violation, the first condition. Second condition is in full, no overlap, which means you have only two choices. Okay, either left or right or up and down, right? No other choice. So this is easy. This is Y, this is X. So if it's left and right, so the this uh, parameter it is if in this case, right? So the X is A plus X, right? This direction. And this one is the maximum, the max of B and Y. This is one way, right? Certainly you have to, I think you have to add up, right? And twice. Parameter means is this one. So the twice of this plus this. If up and down, same thing, right? So this is max of your A and X, right? Plus and Y plus B, right? And uh, twice, and you find the max. That's it. So this problem, I think everybody should can solve it because this is a junior to me. This is a J2 level problem. So let's quickly write the code, okay? I don't want to spend too much time on this problem. So let's quickly write the code. So I'm going to here create. So this is CCC 25 S1 dot. We are using CPP, okay? And then I'm just use CPP. Quickly write the code. So here, what you need is four numbers, A, B, and X, Y. So this problem, I just use A, B, X, and Y, and seeing, right? A, B, X, and Y. And then calculate answer one, right? I have erased it, but in here, right? So what you need is twice of. So first is A plus X. That is sorry, I erased it. So this is A, this is B, this is X, this is Y. So A plus B and right, A plus B and so here A plus B plus max of B and Y. So this is one answer, left and right, and up and down. So answer two equals twice of this is max of A and X plus B plus Y, right? So that's it. And then you just see out the maximum of answer one and answer two. That's it. So this problem should be very easy to solve. Okay? And test it, copy and paste. Do we get 18? Oh, so, okay, 18. And the second one is this. Let's just copy and paste. So this is 20. That's correct. And third one, so copy and paste. Easy, right? 12. And that's it. And then you submit. So I'm going to Control A, Control C, and submit. So submit the solution. I'll have to choose C++, GNU C++, Control A, Control C, submit. Easy. Oh gosh. So let's see. You know what? So this cannot be. How come? So AX. So answer one, answer two. Oh, minimum. So sorry guys, right? You need to find the smallest. So you need to find here. The answer should be the minimum. Find the minimum. Okay. So then I'm not going to test again because this is a simple one. Sorry guys. I think I have to edit my profile and choose C++. So C++, GCC, okay. And do we have update? Okay, so then let's go back. Let's reopen here. And I'm going to submit. Control A, Control V, min, submit. Sorry, guys. So just to use the maximum. Okay, so you see 15 points. We got it. Let's try the second problem. So second one is let's see. This problem is CCC 25S2. It's called Cryptogram Cracking Club CCC, right? And let's check it. It's called the Cyrene, right? The captain of the CCC came across a concerningly long cipher. Conveniently, this cipher is composed of lowercase character comfortingly. The cipher is composed of a pattern that repeats infinitely. I'm not going to read everything, okay, because this problem also, if you understand it, I think this is also a simple problem. Why? I think if you check I'm going to create a new ABITC. So if you check the junior, CCC Junior. Okay, and I think there is a hop tuning, right? Hop, yeah, this problem, right? It's very similar. This problem is very similar, right? Although this is even harder than this one. So what you need to do is here. You have to, I think you have to, so get the occurrence. Sorry, you have to split it, right? So what you need to do is you need to find a way to split the string, okay? And you get something like this. A is 4, B is 1, C is 2, D is 4. And keep in mind, this is not one digit, okay? It could have many. So what you need is to find a way to To split it, okay, I think we can use this example. So I'm going to just copy this, copy paste, do some analysis. Okay, see here, what you need is first, so this problem, you have to split this. A is 4, B is 1, C is 2, right? D is 10. You need to find this, okay, from here to find this. Certainly, this is not a map, okay, not a dictionary. Don't use dictionary because sequence matters, okay. So you should use a list of pairs, right? List of pairs. And once you got it, you have to sum up, right? Totally. This is 17, right? 10, 4, 2, 1, 17. And then this one, remember this is a periodic pattern, right? Periodic pattern, you have to 100 module of 17. So this is 85, right? 85. So the remaining is 15, right? Okay, so which means A, A, 4, and B. Okay, there's one B, and there are two C, and they have 10 D. Okay, so what you need is keep in mind. Also, there's one thing you need to be careful. Okay, so this problem, this is zero based, which means you be careful, okay, a little bit careful. Keep in mind, zero based means this is zero, this is one, this is two, this is three. Okay, also you have four, and this is four, this is five, six, and seven, eight. Okay, keep in mind of this. After that, then you just go through this, right? Go through this each. So remember, this is I just call it the remainder 15. In this case, certainly this is bad because I know 15 must be in D. So, but you know what? What you can do is, what if it's reversed, right? So D first. What if so D? What if it's D first? Okay, 10D, and then 2C, and 1B, and 1A, 4A. So then what is 15 here? Keep in mind, so because it's zero based, so which means this is this is zero based. Okay, zero based, which means this is zero. This is 1, 2. And then this is 9. Okay? This is 10, 11, 12. Still as the last one. Anyway, so be careful about this. Everybody, are you? So I guess most of you should be no problem, right? Are we ready to write the code? So let's write the code. And another thing is for this problem is be careful here. The length, it could be very, very long, the length, but it guarantees. So the length is very long, and but the number. So here, this number it is big, right? So it is, but it is long. Okay. And well, you know what? For this problem, the best way is using Python. Python, you don't have to worry about the integer or long, because for the C++, if you be not careful, right, you will get the int of overflow. So what I suggest is using Python. Certainly, I'm going to use C++ to show you how to solve this problem. Okay. So certainly you need first is this is first step to get this. Second step is go through this to find where is the position. Okay, and I think let's just write because this is a simple problem. Okay, so let's do it. I'm going to shrink this and I'm going to create a new file. So this is CCC 22 25s2.cpp. Okay. So let's using C++. The import is very simple. Okay, it's just the see here. It's just S and what is the number? The number is the C, right? S and C. So I'm going to use CPP. Okay, because if it's a big number, I'm going to put it in the global. So this is a string of S. Keep in mind, I think we are going to manipulate the string. So I'm going to include a string. Okay. Remember, we also, uh, yeah, and we also remember this one. a list of pairs, I think we are going to use vector. So using vector of pairs. Okay. And this is getting a string, and uh, you remember you have to type def long long before you can define this c. C is not an integer, so this is long long. That's it, right? And also, so first let's just read it. Seeing s and seeing of your c. That's the input. Next one is remember the step one, right? Step one, split S into vector of pairs, right? So we are going to define, so here this is, I'm going to define the pair. Pair, first is a character, right? Second one is not int, it's a long long. So I'm going to use long long. Okay, so this is just, I just see PCL, right? PCL. Okay, so then after that, then you have a vector of your PCL. So this is, I just use pattern, pat. Okay, so this is the pattern. Once you have this, then we are ready to to step one, split it. How to split it? What you need is I'm going to use another page. Remember, so A, right? And B, B, C, C, D, D, whatever. Okay. So what you need is a letter, right? A letter. You need a start. You need an end, right? That's all what we want. So you just go through it. Go through the letters. If there's a different, right? Whenever it's different, oh, sorry, guys. I think this is A4, D3, right? C1, H, something like that. So you just go through it and check if this is letter. Okay, so this is letter. Okay, then after that, so this number, this number, so you have more. So this number is always the remember you only need the location of the letters. You don't need the location of this because this one is just get the substring from the position of here of here, this position of here to here, right? You only need the position. So that means you only need this. You only need this. Actually, you don't need this because you are looping it. Looping the this is R, this is left, right? You are looping it. So let's just once you know this, I think there are many ways to do it. Okay, I'm going to implement in my way. So what I'm going to do is I'm going to character. This is a letter, right? Certainly initially. So initially you need to find a letter which never appears. So what I'm going to use is this letter. I'm going to just put a space. Okay. I know space never appeared. And then this is your left, right? So left initially it's zero. Initially it's zero. Okay. So remember the here. So remember, I'm just using this, or maybe I just use it as start. So let's just do it as start. Okay, so these are the two things. And also another thing is, remember here, we have to add up, right? Add up. So that means that I'm going to define a long long, right? So this is a total occurrence, right? Total numbers, total, the sum up, okay, of all numbers. That's it. And then after that, then just for int of I starting from zero, I less than s dot length, right? And then I plus plus. Just loop it, okay? Loop it, and certainly only you stop only when this is a letter. So this is si is a letter. So stop only when it's a letter, right? If it's a number, I going to skip it. So only when it's a letter. Then you have to So only when it's a letter, see here, only when it's a letter, I'm going to stop. And I'm going to process it, right? See here. So I'm going to process. Certainly, this is you can for the C++, you can just define, right? Define a Boolean is letter. This is very easy, right? Character of X, and then just return, right? X is greater than or equal to A, and right? And X is less than or equal to Z. That's it, right? So this is going to check the letter, okay? And once we have this, if it's a letter, then then you certainly if it's a space, right? Your letter cannot be space. If only when it's not a space, because if it's a space, you are starting you are starting from it. Or if you don't want it, you can start from one, okay? You can start from one, right? It's up to you. So many ways to do it. So if it's not empty means you remember here you are at here, right? You're at here. You have to put them into that vector, right? So let's do it. So first is you need to you need to get the number, right? So this is string of number. So string of number is s dot substring, right? Okay, substring from where to where? Okay, so substring from where to where? So this one substring from where to where? Because wait. So then start, right? Start plus one, and minus start. Is that right? I think let's see. Remember, we are going to accumulate. We are going to accumulate the see here. This one, right? We just want to get this number. Let's just check it. Okay, remember this is zero based. So zero based. So okay, so this is zero. I think we can just make it start from one. Okay, and actually this is make I can make it starting from one. Okay, starting from one. So then we don't need this, right? We don't need this. We start from one. I know that if it's a letter, we have to, oh, I think that's wrong. Sorry, guys. Cannot start from letter. So we have to start from zero. Okay. Why is that? Because if it's if it's so if it's not this start and I minus start, why is that? Because suppose this is your start. This one is your start. Okay, and this one is your. Remember, this is first letter. Okay, so how many do you have? So this one minus this one, right? This one minus this one. Suppose this is three. This is five. So two, right? Okay, so this is right. And also, the thing is, you be careful, right? Be careful. You need to know how to convert into a long long, not a integer. Long long. So long long num equals. You need to know this stoll string to long long. Certainly, you have to include this string. So you need to know this. If you don't know this, I think you better to use Python. Okay. So once you have this, then str num. So this is a number. And once you have this, then pat, right? Push back a pair, right? A pair. So the letter and num. Put them in a pair. Okay, and certainly, don't forget to sum up, sum up the number. That's it. As I said, if it's not letter, if it's not letter, certainly you have to update your letter. So update your letter, okay? And certainly don't forget to so update your start because the start always after the letter, okay? Start always after the letter. Let me put it here. So start always, right? After the letter. Because for the next letter, then you know that this is a number. If you made a mistake, it's not a big deal. You can always test it, right? Okay, so then once we are done with this, once we are done with this, but be careful, okay? Be careful because remember the last one. The last one. The last one is not a letter. So you still have something after the for loop. After the for loop, you have to copy paste this, okay? Because after the for loop, you need to copy paste this. Why is that? It's because the last one, right? Last character cannot be a letter, which means you have to put the last letter into your pad. Okay, and certainly you have to change this. There's no I here, right? So this one is actually it is s dot length, right? S dot length. So update this, and this. I think that's it. We are done with the first step. Okay, although it looks simple, it's supposed to simple, but we wrote quite some lines of code. Step one, we are done. And now let's go to the step two, right? Step two, find the position. Find the letter, right? The first thing is remember the remainder. So the remainder will be the C module of your total, right? Module of total. Okay. So this is the remainder. Once you have the remainder, so this is your answer. So I'm going to put answer and a space and then just loop it, right? For int of I equals 0, I less than pat dot size, right? I plus plus. Go through the pattern, and then so get the number. So the number is pat of I. Remember, this is second one, right? Second one is the number. Okay, and then compare. If your remainder is less than m, if your remainder is less than m, for example, if it's zero, zero. Zero means the first one, right? So if A has 4, B has 1, C has 2, D has 5, so E has 6, 7, F has 1, something like this. Keep in mind this is zero based. So zero based means 0 to 3 is this. Okay, 4 is this. And 5, 6 is this. Okay, so you can see add up. This number has to be less than this number. So if it's less, which means you got it, you got it. So the answer is your pat of dot first, okay, and then break it. That's it. And don't forget when you go through it, right? Your remainder you have to reduce the remainder, right? So reduce the remainder, right? After if this one is not the right one, your remainder you have to reduce the number. Okay, so that's it. After that, then see out. See out your answer. Okay, and let's test it. Okay, so this is R. Second one is let's run it, copy and paste. So 100, this is D, right? Okay, and so let's submit. Submit the problem, the solution, and so Control A, Control C, and Control V. Don't care about those warnings, okay? Because only this kills, right? So only this kills. So I got 15. That's it, right? This problem, it's not hard. It should be very easy to figure out, okay? As I said, if you're using Python, maybe should be even simpler, okay? Python, you don't have to worry about this STO area. You can just convert the string to integer. Python doesn't care about the overflow things. I don't have time to write Python, okay? You guys, if you want, you can try with Python. I can tell you Python is simpler. Okay, so then I think most of you, right, guys, should have no problem with the first two problem, right? Now we are going to the hard ones, okay? The hard ones. So let's just go to here, okay? The pretty pants. I heard lots of students stuck with this problem, okay? And now I think let's let's see why you guys are stuck with this problem, okay? So let's take a look. This pro so this is CCC 25S3 pretty pants. Okay, so actually I'm not going to read. Let's just quickly read it, okay? Because I assume you already understand the problem, okay? This is a art class. You are so this is you just pay attention to the critical details, okay? You have M pens and you have M colors. Okay, Justin is here. So M pens and M colors. Initially, the color of ice pen is CI. Okay, additional, your pen are pretty. It has a prettiness. Pretty. Okay, okay. For your assignment, you need to create a picture of using. This problem. Actually, it's already simplified. Why? Did you notice this is the same as this? If it's not the same, if this is less than this, I think then the problem will be more complicated. Okay, now it's already simplified. So this picture always you always using M colors to make M strokes. Okay, so that is why this problem is this is a make your life easy. Okay, make your life easy. Each from a pen of a different color. The prettiness of your picture is a sum. This is easy, right? Easy to understand. So what you need is to sum up the used pen. The used pen, use the pretty, pretty, prettiness. Use the pretty, okay? Your teacher has given you some room for this. You are allowed to change. This is, why? Because if you don't have it, this is too easy, this problem. So that's the reason. They want it to make your life a little bit harder. Means, you are allowed to change one pen to add the prettiness. After the picture is drawn, pen will revert back to its original color. This is also make your life easy because you have you will have many assignments. Okay, each assignment it doesn't. So the previous assignment doesn't affect this one. Doesn't affect the next assignment. Okay, and also now here to push your creative limits, your teacher also has queued more pictures for you to create. Okay, don't care about these things. Okay, this is not relevant to your problem. Okay, and this is important. So you are going to have two for the next picture, right? For the next picture, you are going to each picture. So two of the possible change to the set of pens. One is to one is to change the color for that pen. So pen I change the color to change pen I to color C. That is first change. Second one is you are going to change the prettiness prettiness of pen I to P. Okay, pen I. So these are the two modifications you need to make. For each picture. Okay, and also another thing is the change are executed sequentially. So the first change modifies the initial setup, second change modifies the blah blah blah, and also as in the first page you're allowed to change. Also, this is the same. Okay, you are allowed to change one color. Note if you do change the color of one pen, it affects only the picture you are drawing, not the next one. Okay, so that means this you change the color of the pen only affects the picture you are drawing. Okay, not others. Okay, and now the question is, what is prettiness? Prettiness of the prettiest Q plus one picture you can create means maximize the sum, right? You are going to maximize the sum. Okay, I hope everybody understands this problem. Okay, understand it? Okay, then certainly at first you have no idea what is it. Certainly you have to check the samples, right? Samples. Certainly I'm not going to read everything for the import. Keep in mind this number could be it's very big. Okay, it's 10 to 5. 10 to 5. Yeah, this is also 10 to 5. That means you no loop. Okay, no loop is allowed. So don't ever think about using loops. Okay, no loop, because you already have this Q. Q is already a loop. Okay, and certainly this is 10 to 5, and for each operation, right? For each when you calculate the sum, you only allow the log n. Okay, log. So this is one only allowed, not others. Certainly, if it's constant, then still no problem. The next one is CVO. The import is give you N, M, and Q. So this is the number of pens. This is the number of colors. This is the number of the Q. Okay, Q means more pictures. And after that, then each pen, right, has the color and has the prettiness. Okay. And another thing is very important is this one. This is very important. This is also make your life easy. Okay, it's guaranteed. Okay, which means for each picture, each color always there's at least one pen. Means you will not have so this color doesn't have a pen. It always has a pen. Makes your life very easy, much easier than okay, much easier than it should be. Okay, so once we have this, still initially you have no idea how to do it. So what the best way is to is to check the sample. Okay, and keep in mind first 5 points Q is 0, no change. I think this should be easy, right? If you cannot solve the whole problem, I think this 5 points shouldn't be hard. Let's take a look. So I'm going to copy this, control this, put it here. Okay. So we have 6 pens, 6 pens. This is let me just make it bigger, make it even big. Okay. So this is pen 1. Okay. This is pen 2. This is pen 3. This is pen 4. This is pen 5. This is pen 6. Okay. And now you have to check the color, right? This is the color. I think everybody should know this color, right? C1, color 1, color 1. It is pen 1, right? And the prettiness is 6, right? Okay. And color 2, so C2, right? P2 of 9. Okay. And color 3, P3 of 4, right? And color 4, so sorry, this is color 2 again, right? So this is P4 and 7. Okay. And this one is color 3. This is P5 and 9. Okay, and then this one is color 1, right? So this is P6 of 3, right? Everybody knows this, right? And I think once you have this, right? So if no cube, I think everybody should know this, right? Pick the maximum, right? The highest. Pick the highest. Pick the highest. Okay, so total is 6 plus 9 plus 9. It is 24, right? Everybody right? Before you change color, okay? Because before you change change color, right? You need to pick the highest one, right? Pick the highest one. Now you're allowed, right? Remember, you are allowed to change one color, which means certainly you need to find that this is the smallest one, right? So what does that mean? It means you need to find the smallest p, right? Pretty. This is the smallest. You don't want to change. You don't want to change this and this, right? They are already very high. You want to find this one, and find the smallest used, right? Used, pretty, right? I'm going to hide. I think I'm going to use this. This is used, right? This is used. This is used, right? You find the smallest one, and remember all others. Like I'm going to use another color. So this is not used. This is not used. This is not used, right? You certainly find the maximum. This is the maximum, right? 7 is the maximum. Replace this, right? Replace this, which means 6 becomes 7. So you increase 1, right? And the answer is this plus this, 25. Everybody, right? So the answer, why the answer is 25 is this, right? Okay. So now here's the question, right? Here's the question according to our analysis. So here is, you need to know that for each color, right? For each color, you need the highest one, right? You need the highest P, pretty, not this P, okay, this P. You need the highest one, right? Okay, and also, so this is for sure. And then sum up, right? Sum up this number. Second one is, for the use the pen, use the prettiness, use the pretty. You need to find the minimum, right? Min P. Find this number. And you need to find for now, I just say unused. You need a unused. These are unused. You need to find the max P, right? Okay. And certainly it is possible this number is greater than this number. If you don't have this, right? If you don't have this, then you cannot replace it, okay? You cannot, right? Don't replace it. Only you have this number is greater than this, then replace it, right? Find this, certainly this is unused P, the maximum of unused P, okay? Unused P. This is the minimum of used P, right? Used. So all the used. That means you can, for each pretty, right? These are the prettiness. So that means you need to so split them, right? Certainly, used only has one, but you could have many unused, right? You could have many unused. You could. That is for sure. Okay? And certainly you could have many colors. That is before we talk about before before this happened. I think hopefully everybody, now the next thing is find the right data structure, right? Find the right data structure. This is also important, right? First step is you figure out you need these three values. The so you need to find the highest, and you also need for the used. Those used you need to find the minimum. For the unused, you need to find the maximum. You need these three things. Now the thing is next one is what is the data structure for it? To find the highest, I think what set, right? Using set. Okay. And also, did you notice that actually after you do this, you can simplify this. Why? Actually, this number is useless. You don't need this number. You don't need this number, right? Useless. This is useless. Which pen, I don't care. I only care about the prettiness. Certainly, if you do that, certainly you could have multiple values, which means you need to use multiset. This is sorted. Okay. If it's in descending order, certainly the first one is the highest. And that's right. Everybody right? So for each color, define a multiset. So this is done. No problem. You solved it, right? Okay. And the next thing is, so how to find the minimum of the used, which means you know this one is not enough. Multiset of each color is not enough. This is each color. Multiset of each color. This is not enough because you only use this doesn't solve these problems. Okay, doesn't solve these two. Why? Because you don't, as I said, this problem no loop. Okay, cannot use loop, which means what you can do is put all used p into another multiset. So put this in multiset also. After that, then immediately you know the minimum, right? Multisets, the goodness is it's ordered. Okay, it's ordered. So then either the head is the minimum, or the tail the start is the beginning is the minimum, or the end is the minimum. It's up to you, your definition. But we know the multiset is ordered. Is ordered, okay, and we know the time complex is log n. Okay, so this problem, the trick is put all these used into one multiset, put all the unused into another multiset. So what you need is, I'm going to create another page, okay? Another page is, what you need is, first is, for each color, you need a multiset, okay? Multiset for all prettiness, for all P's, prettiness. And the second one is for used, okay? Used prettiness. Put them in another, also in a multiset. So this is a lot of multiset here. Each color as a multiset. This is for all used, and for unused, also put them in multiset. If you do that, then you can calculate this easily, right? Calculate these easily. Okay, so we are done with we are done with 0Q. The problem is what about the change, right? You have two changes. One is, remember, one is change pen color, right? Change pen I to color C, right? Okay. Another one is change. So pen I, prettiness to prettiness to P, right? You have to. So the thing is, I think the hard one for this problem is how to deal with this and this. Okay, everybody. So this is hard. So how to? I think maybe the second one is a little bit simple. Okay, simpler. Why? I think you have to deal with second one first. Why? Because remember, first 5 points. If you find this, you are done. And for the 2 points here, did you see that? M is 1. What does that mean? Everybody, do you know what's the meaning of this one? M is 1 means one color, right? So this is one color. One color means for this one, for this test case, you cannot change color, right? So that means on this, you deal with this later, okay? Later. You should deal with this first, okay? Why? Because for this test case, always 2. Type is always 2, right? Always 2. You cannot change color. Only one color. How can you change it? So you are going to deal with this. We deal with this first. So now let's take a look at this. Let's review this, okay? Review this. So for example, pen pen I, right? Now I have a new pretty, okay, new P. What does that mean? See here, uh, you know, you so so P, uh, so you are going to change the P, right? So how to, you need a model set of prettiness for each color. Remember you saved this, right? So that means you know the current color, right? You know the current color. So find the current, for example, you are changing this. If you are changing this is your current color. Sorry, this is current prettiness. I think then what you can do is see here, you see here, each color, right? You know this pen, which color currently, this pen is with which color. You know the color, right? You know the color. And you are going to, I think, also you know the prettiness. Why? Because you know this. You know this. So just remove, right? So remove the old P. Okay, insert. I think it's called erase, right? Erase old P, insert new P, right? Insert new P. Remember these operations are log n. Once you are done, you still can get the maximum, right? Everybody, right? And certainly you know before you do the erase, you know the old max, right? Old max and new max. So remember you keep the answer, right? Your answer just update, multiply equals the new max minus the old max. Everybody right? Because you are only changing one color, one pen, one pen, new the old P, new P. So just manipulate this for this color, manipulate this multiset. So erase the old one. Before you erase it, so store the old max. After you erase it, insert the new P, find the new max. And the answer must be the new max minus the old max. Everybody right? Because other colors you didn't change. Everybody, do you get it for this problem? The idea is, I'm talking about this one, okay? So we are changing the we change from the old prettiness to the new prettiness. So just erase the old prettiness, insert the new prettiness, and then find the difference of the max, and then answer it. But remember, you have to replace, right? You have to do the replace. What about the replace part? Do the same thing, right? Do this. Remember, you find the old max, new max. Okay, you know this. The old P, is it used or is it not used? If the old max is the same, if the old max is different from the 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 old P, right? That means this is unused. So update unused. And the new P, you know, just use certainly there are some logic there, right? Logic is there. You know what? I'm not going to talk too much details. I think I'm going to implement the code, and when I write the code, I show you. Okay? Because so what you need is to remember you have old P and new P, right? You just need to figure out this old P is used or not, this new P is used or not. Just update this multiset, then find the maximum or minimum or whatever, right? Everybody. I think I cannot talk too much details here, okay? I'm going to talk about this when I'm writing the code. Is that okay, everybody? Everybody, is that okay? When I'm writing the code, you will see. Why I can tell you this problem, it's not really very hard, so hard. The hard one is when you write the code, you be very, very careful. Okay, as I said, you need to know when to put the old P in the used, when to put the old new P in the unused. Okay, so there are only four situations, right? New P is used or not used. Old P is used or not used. Only four situations. Once you update the mod set, then you know the this one is the maximum and the minimum of this, right? Then you can replace. Everybody right? Okay, I hope you understand it. I think if you don't understand it, you can unmute yourself or send me message. Okay, guys, Elliot, do you get it? Just at this time, just to get the general idea. Okay, because some details you have to do it when you write the code. Okay, just just understand the general idea. The general idea is you are going to have this, the multiset of each color. You need a multiset for the used. You need a multiset for the unused. Okay, that is the general idea. And so for this, we will see when we write the code. Okay, when you change the pen, change the prettiness, you just need to update the multiset, right? After that, then the max or minimum multiset will automatically give you. Okay, so I think let's write the code. Okay, so let's write the code. What I'm going to do is so CCC 25s3.cpp. Okay, and so CPP this problem. I think this problem. I don't know. So I'm going to use CPPX, okay, because I'm worried about the time limit. Because the size is very big. I'm going to use sync with Studio Zero. Maybe if you don't have it, it's still okay. Okay. So and also we are going to have this N, M, and Q, right? This is for sure. And constant interval. I'm just use MX, MX. So this is 2E5 plus 1. Okay. And now, before we do anything, okay, let's see. I think we also need to save this, the, the pen, right? Save the pen. So that means I'm going to define a type def, a pair, right? Int of int, and this is PI, right? And then we, PI pens, right? MX. We have to save this. So save the color and the prettiness, right? For each pen. We have to do this. This is definitely we need it. And also remember I said we need let's just include the multiset. So set, okay, and then we are going to have this multiset is part of set, okay, multiset, okay, and also another thing is if you use this, so this is colors of MX. So save prettiness for each color, right? This is remember for each color you have to save it a multiset pretty for each color. Okay, so all the pretties. Okay. You know what? I think to make your life easy, I think it's better to use this greater int, and it's better to use this. If you use greater, that means this is descending order in descending order. Okay. Certainly, if you're using ascending order, still no problem. Okay. Ascending order also no problem. Descending order maybe will make your life a little bit easier. Okay. And also you are going to have another multiset, right? Another multiset int. So used and unused, right? Okay. We are going to have this. This is multiset. And you know what? If you want, you can also make a unused make a greatness. But I'm going to show you if it's this. So these two are in ascending order. Okay, these two are in ascending order. Okay, I will show you in ascending order. It's also not a problem. Okay. Okay, once you have this, now what? We are going to read, right? So for seeing of your N, M, and Q, right? So read three numbers and then for interval I equals 0, I equals 0, I less than n. So n pence. Okay. And then we are going to read the color and P, right? Prettiness, C in C and P. And then you know what? This color is 1 based. So we are going to make it 0 based. So make it 0 based, okay? Why? Because 0 based easy, right? I don't want 1 based. I just based on 0, 0 based. Once you have this, then you pen. So pens of your eye, right? So ice pen. I is also 0 based. Ice pen. So here be careful, okay? So anyway, so this is I'm going to put a pretty first, put a color second, okay? This is I think for pen is also no problem. So this is a pretty and color, okay? And then here, so the colors. This is colors for each C, right? Remember, this is C. You have to insert, right? Insert the prettiness, okay? Right? So put P pretty in the set of color C, right? Okay. So we are done with the first step. So first step is step 1, right? So put all uh, pretty in colors. Okay. And this is step 1. And step 2. Step 2 is I think you know this is certainly this problem. Should we use Lang? So I think we need to check, right? The prettiness, oh, 10 to 9. You add up, it will be Lang, right? So that means you have to use Lang, right? Type def, Lang. You need Lang, okay? So then once you have this, we are going to calculate, right? Calculate. Certainly first. So first is I'm going to use total, accumulate, right? So add up the max pretty for each color, right? Okay, so this is easy. So you just loop through the color, right? C starting 0, C less than M. This is fixed, right? M colors, M colors, and then so for each color, right? For each color, right? Then what? We are going to loop. We are going to loop through all the colors. So let's loop it out of your iteration of your CS of C, right? Begin. Okay. IT is not equal CS of C dot end and IT plus plus. So iterate all colors. This is end bracket. Uh, iterate all colors for all pretty, all P for color C. For color C, okay? Why we need it? Because we are going to put these into used or unused, right? Okay. So for each color, remember CLS is in descending order. This is in descending order, okay? Which means the first one is used, right? So int of P, int of your I already have P here, so maybe I just use P. So this is the value. Okay, and if your IT equals right CLC dot begin, this is a used, right. This one is the largest one. Okay, which means this is used, right. So that means I'm going to put it into used. Okay, and then don't forget to total plus it, right. Okay, otherwise it's not used, unused. right, everybody? So quality used or unused. Okay, so once we have this, after this loop, right? After this loop, so we are going to tote, we are going to define a function called a replace. We are going to remember the change color, right? So we are going to define a function called replace. So this is going to return the long. Okay. Actually, return int is also okay because p the difference cannot be big, right? Long is also okay. So then what to do for this? So find, right? Find the max of unused, right? Find a minimum of used, right? So that means you need to make sure unused, the size unused, the used, the size can it has to be greater than zero. Otherwise, it is possible or used, right? There's no unused. It is possible. So only when there's unused. So then int of your p1 equals what? So unused. Okay, begin, right? This is a I think you should use our begin. So this is the largest p, right? Largest unused p, right? See here, this is in ascending order. So the R begin is the largest one. And also, there must be used, okay? Used cannot be size zero, okay? So this is used begin, okay? And then you are going to use this star. This is the minimum, the smallest, right? Used P, right? And then just return, right? If P1 is greater than P2, then P1 minus P2, okay? Otherwise, don't change, okay? It is possible. It is possible the maximum is less than this number. If this is 5, this 5 don't replace this 6, okay? Okay. And certainly if no unused, then it is 0, right? Okay. And you know what? I think if our code is correct, we already got 5 points, okay? So what we can do is for int of q equals 0, you have to read all, okay? And q less than capital Q and Q plus plus, right? Yeah, you have to read all. So if you Q, then you have to read three numbers, right? Three numbers here. I C. So int of x, y, and z. So seeing x, seeing y, seeing z. Okay. Don't do anything. You don't need to do anything. Okay. Because certainly you can also see out this. This is for sure. You have to do it. But we at this time, let's skip this first, okay? Because we want to test the first case, right? This one. Do we get 25? We get 25. And if you submit, you will get 5 points, right? So let's see. Let's see. Do we get 5 points? So let's see. Do we get 5 points? Yes, right? We got 5 points. Good. Okay. So next one is let's go back. Let's going to deal with this one. M equals 1. No change color, which means here. Now, so I'm going to erase this, right? So then what? If, right? X equals 1, I'm going to pass first, okay? So skip to do later, okay? I'm going to deal with x equals 2, right? Because I know x equals, so this one must be x equals 2. Only one color means you can only change the prettiness. Okay, so now the hard one. Here is the hard one. Really, you be very careful. Okay, so what is this? So this is to change the prettiness of the ice pen. Okay. So that means what? First, you need to remember zero based. Okay. Color zero based. Okay. So reduce zero based. And now here, a good habit is when you are dealing with a tough problem, better to write comments because when you make mistake, you can understand what you are doing. Okay. So this is pen. Okay. I, sorry, pen. Y. Sorry. Uh, so okay. So I think this is pen Y. Okay. Pen Y. Change. So this is pretty okay. To P, right? No change color. Okay. Color not changed. Color. Color not changed. Okay. Right? Change pretty to P. So, you know what? Certainly, you need to find the old P, right? Old P equals, remember the pens of your Y. So this is the first, right? And oldest, so this is just the old C, just as a C, right? Pens of Y of your second. Change color, no change. C is the color, P is the prettiness. Okay, once you have this, certainly I think you need to check, okay? So your Z is not equals old P. If it's the same, don't change. If they're the same, no change, right? You didn't change the prettiness. Z is the new P. So if the new P and old P are same, don't do anything, right? Okay, so the first thing is you are going to pens Y, right? Equals. Remember, you have to change Z and C, right? Okay, so P is changed. P is Z now, right? Change the P. Okay, now here is the hard ones, right? The hard one. We need to update the three. So we updated this. We need to update this and this and this. Let's do it. Okay. So let's update. So I think you know what, CS. So update CS. Okay. Update CS of your C, right? Okay. So this is a mod set. How can we do the update? What we can do is auto equals CS of C dot begin. Okay, and this is unused. Actually, this is used. Used. P1 means the old used P. So this is this, right? Everybody, let's just write it. Used P1 is the used P before change, right? Everybody, right? Because this is descending order. The first one is the used one. Okay. Okay, after we got this, then what we can do is, remember, we are going to erase, right? Okay, we are going to erase this used P, right? Sorry, erase the old P, right? Replace the Z, right? Okay, but don't do this, okay? Please don't do this. Don't do this, okay? Never, never do this. Why? This is a multiset. Multiset, if you do this, you are erase a lot. Same, there could be a lot of same numbers. So you have to use CLS this dot find. You need to do this, okay? Only erase one value. Only erase one value, okay? Don't directly erase old P because old P could have many old P. Just erase one. And then just insert, right? This Z, just insert Z. Okay, everybody, right? Our CSS is good now, right? Updated CS. CS is good now. We erase the old P. We insert the new P. Okay, but we need to update this used and unused, right? So to update the used and unused, what you can do is int of it2, right? CS begin. Okay, let's find the why I got red ones. Okay, sorry, this is auto, okay. AUTO. This is iterator. Iterator. And then int of used P2, right? Equals IT2. So this used P2. Used P2 is the new used P, right? New used P, right? Everybody. Because I erased the old one, insert Z. Now I'm asking what is the current used one, right? The maximum. This is the descending order, the maximum. Okay, so then we are going to compare, right? Okay, remember, if used P1 is not equals used P2, guess what? If they are different, guess what? If they are different, then what? If they are different means the new Z must be the used one. Everybody right? And certainly, you need to update your total, right? Remember? This is easy, right? Because the new P and the old P, right? Used. This is a new P. This is old P. Your total. Remember, this total is increased or decreased, right? Okay. And so yeah, here's a tricky one, right? So now we need to we need to we need to update used and unused, right? So how to do that? Okay, so you know what? Remember we have this old P, right? So if your old P is less than used P, guess what? If your old P is less than used P, means the old P is unused, right? Old P is unused, right? If it's used, it must be the same, right? Okay, so which means you used. You have to erase, erase what? Use dot find, use the P1, right? P1 is the old use, right? You should erase it. Okay? And then remember, old P is different from the new P, which means this one is unused now, right? So unused, you have to insert used P1. This is unused, right? This one become unused. Everybody right? And certainly, you have to remember the old P is unused also. Unused, erase of your unused dot find of your old P, right? And your used insert, you have to insert Z because these two are different, which means Z must be used. Everybody right? The logic. And also you need to know that whenever you erase used, you have to insert used. Used is the size should be always the same. So whenever you insert unused, you have to erase you. So this has to be paired, okay? There's one erase, there must be one insert. There's one insert, must be one erase. Why? Because the size always used and unused. Used always M, okay? Size is always M. Unused is always the fixed, okay? So be careful. When you erase something for used, you have to insert something. When you unused, you insert something, you must erase something. Okay, this is the logic. Be very, very careful, okay? Because one small mistake, you want to get the answer. Okay, we are done with this case. We are done with this case, okay? Which means this one means the Z is used, right? Because if Z is not used, these two should be the same, right? Okay, otherwise, else. Okay, else what? Else means what? So this means, you know what? Because this is different, which means pen Y changed from used to unused, right? Okay, So this means pen Y changed from unused unused to used, right? Only in that case where it will be different, right? If it's used, so only that is will be different. Uh, I think what if changed from used to if they are different, changed from used to unused. But what if just increase used to used? So what if it's used to used is still different and outer P is the same. Okay, so that means could be changed from unused or used. Let's see. So that means anyway, I think used you should erase. Oh, find your old P. Okay. So what if it's used to used, but still need to erase the old P, right? Because the new P you have to the old P is always gone, right? Okay, and then unused. If they are different, so unused. So I think of Z is. So what if the used P2 is Z? So this is insert Z, unused. So I'm thinking, did I have some logic problem here? So used and unused, if it's different, old P not old P is less than this one, which means the old P is. What if the old P used P change from used to unused? Changed from used to used. Used to used. If it's that different. Anyway, so let's just so here from used to unused, then Z is unused, and then unused. Okay, erase. Used dot find used P2. Okay, because P2 is used now, right? P2 is used. So used dot insert of used of P2. It's logic. So you know what? Sometimes I don't worry too much. Let's just test it. Can we pass the second test case, right? So this one. Certainly it doesn't work because there is there is one here. But we can submit, right? To see if the second test case, can we pass it? Control A, Control C, Control A, Control V. Oh, okay. So TLE means uh, how come it can have TL? Oh, uh, so you know what? So we didn't think about what if they are the same, right? So here we what if they are the same? So if they are the same, if they are same, that's easy, right? If they are same, which means both are unused. Okay, so the both are unused. Unused, erase. So unused dot find of old p, right? And unused insert unused. So insert z. That's it. So I think let's just Control A, Control C, submit, resubmit. I just want to check if I can pass the second test case. Oh, looks like something is not very right. Okay, so got a TLE. How come? Q less than if equals one to do. Old P and old second and Z not equals. So we modified auto IT begin, use the P1, find old P. Something is wrong here. So CLs begin and IT2, if they are not the same, you need to make sure unused, used, used, unused, unused. Oh, here. Gosh. So once, as I said, one stupid mistake will ruin everything, right? So let's just resubmit. Control A, Control C, and Control V. Okay. See, we passed the second batch, right? We passed the third batch. How come? So we also passed the third batch. That's really strange because we haven't implemented this yet. Okay. Okay. So now let's implement this. Okay. This is even tougher than this one. Uh, okay. So let's do it. You know what? I think if if change from used to used, it's not a big deal. Why? If it's used to use, then this one is z. Okay, so that means your insert z, your erase z doesn't matter, right? It doesn't matter. Okay, right? And used means your old p is used. Your this one is z. So this also includes this. Okay, no worry. Okay, so now let's last piece, right? This one is the last piece. Also, be very, very careful, right? So this one is also I'm going to y minus minus. This one is pen y change color to z, right? Okay, so be very careful. Okay, so then this is p equals pens of y dot first, no problem. Okay, and c. Now you have old c, right? So this is pens y dot second old c. Okay. So you don't have the so this is p is the same. Okay. So you don't need old p. P is the same. So just change the color. Now keep in mind. So you need to just check this z is not the same as old z, right? Z is not old c, right? If it's the same, no change, right? Okay. And certainly another one is this is easy, right? So this is easy. This is P and Z, right? Update the pen. Okay. prettiness and the new color. Okay, and then I think we are going to do the same thing. Okay, so out of IT1, right, equals CS of your what? Old C, right? Dot begin. And so this is used P1, right? Equals IT1. Do the same thing. Now CS of your old C, right? You are going to erase what? Of your CS of your old C, right? Dot find what? P, right? Find the P no change, right? But you need to change color, so you need to erase it, right? Erase the old C. This P is to the new C now. Okay, now what? Do it again. IT of 2, right? CS of your old C. Dot begin, right? And get the use of P2, right? Equals IT of 2. Then you check, right? If used P1 is not the same as used P2, what? You erased the used one, right? You erased the used one, right? Because they are different now. Erase the used one. So then what you need is, certainly you know, you are total, right? You still need to use the P2 minus use the P1, right? Your total is changed. And then erased, right? Erase the used one. Erase. Used one, erase. Used dot find of your P, right? Okay? And be careful. You erase the used, but the used is gone. You have to move the unused, right? Unused dot, you have to move unused find of your old one, right? Sorry, use the P2, right? This one is the new one. And you have to use insert, right? Use the P2. Right? I think that's it, right? Because this is a new used. You have to move from unused to used. Okay, otherwise, this is easy, right? The P is not used. You erase the non-used. So that means just unused, right? Erase it. Unused, find your P, right? Erase it. It's not used. Okay? And do the same thing, right? For the new, this is for old color. For old color, right? And then let's check the new color. So for new color, okay? Do the same thing. Out of your 1 equals CS of your new C, right? So this is Z, right? Z dot begin, and then int of used 3, right? So this is IT, I think it's 3. Sorry, shouldn't use 1. 3. Okay, and then out. So then now you are CS of Z, right? You have to insert of your P, right? So P is changed to new color now. Then you just out of your IT4 equals Z dot begin. Okay, and then int of used of P4 equals 4. And then now you are going to check, right? If used P3 equals used P4. This means the new color is not used, right? New color not used. New color not used. If it's not used, then just insert into unused, right? Unused insert of your P, right? Everybody, right? Okay. So otherwise, else, which means so new color is used now, right? Because uh, it's different. So different means now your total, right? Don't forget to update your total. So this is used P4 minus used P3, right? Okay, and then remember used used you have to erase the old one, right? Used dot find your used of USED of P3. Erase the old one, right? Erase the old one and use the dot. So I think you need to find the unused. Remember that this one is erased. Actually, it's not erased. It's moved from used to unused, right? So that means insert, right? Okay. Uh, Used of P3. This is just a move. Move this one to unused. And then you have to use the insert of your P. Sorry, used of P4, right? Remember the P4 is the new one. I think that's it. Okay, that's it. I'm not 100% sure if I have bug or not, but let's just go back. Now you can test this one. You can test this one. Okay. Do we get 50 and 50, 55? Okay, so we got right. And now do we control C and let's submit. Okay, control A, control V. Do we get it right? So let's pray. I don't know. Because I can tell you the idea is correct, but could have bug. Okay, I don't know because you have to be 100% super careful. Okay, one stupid mistake, you ruin everything. Okay, so this is very why this problem is so tough. You see, I wrote so many lines of code. Okay, be very careful. Danny, I don't think I'm going to send you the code. You have to write the code by yourself. Okay? Why? Because copy people's code is not very good. You understand the idea, you should spend time write it by yourself. Okay, see, 15 points. Very good. Okay? When you solve this problem, you feel good, right? Okay, sorry guys. We spent a lot of time on this problem, but I think I'm glad we solved it. I think let's talk about the last problem. That one also stuck a lot of people. Okay, so this floor is lava. I'm not. So this is the CCC 25S4 floor is lava. I'm not going to read everything because I think you guys know it. And you know what? The import is very standard. It is this is N, this is M, and you can see A, B, and C. C is you can think this is cost, right? Chili. So chill level, right? Chill level. You know why you guys are stuck with by this problem is because you never seen such kind of problem before. It is looking for the minimum cost, but the problem is it's not really the minimum. You know, from here to here, you have zero. You have to add three, right? And from this to see this, you have to add one because you need the difference. Okay, so I know why you guys, if you never seen this kind of problem before, you are at a loss. You at a loss, which means you have no idea how to solve this problem. But you know what? Even though you don't know how to solve it, you should definitely try the the dummy way. Why? Means the dummy way means brute force. So try. I can tell you this problem. Brute force works. Okay. Before I introduce the correct way, I'm going to tell you the brute force. Let's just I think let me just copy paste. Okay. Copy paste. So what is brute force? So just a brute force. Okay. Certainly the brute force itself won't work. Okay, but you need some optimization. Okay, optimization. Before I introduce the correct way, okay, I'm just introduce the brute force way. So I think there's no, I don't think there's anything I can tell you about it. What you need is try it with brute force. So this is CCC 25S4.cpp. Okay, so first let's try. the dummy way, which means brute force. Okay, which means we are not going to use diagnostic. Okay, we are just try one all situations. Okay, so what you can do is certainly, let's just the CPP. Certainly, I think for this problem, certainly I worry about the time limit. I'm going to use this. So then first is I think the input is very standard. Okay, uh, this problem also it need a long okay because C 10 to 9, you need a long. So let's just type def long. So brute force. What you need is so int of n and m, right? And you need a vector. So you need a vector. Include the vector. So vector, VCTOR. And so this is you need a pair, right? You need a actually, yeah, you need a pair. So I'm going to type def. This is a pair of int, PII, and then PII. This is adjacency list. I think everybody, oh, okay, so I also need a constant of int of mx. So the mx, if it's here, right? 2e5. So 2e5 plus 1. Okay. And then this is for sure adjacency list. Let's just read. Okay. So seeing n and m. Okay. And then for int of I equals 0, I less than uh, m, right? So edges. So these are the edges. So that is the ADJ. So sorry, int of ABC, right? Seeing A, seeing B, and seeing C. And then, so ADJ of your A dot pushback. So first put B and C, right? Second ADJ, because this is bidirectional, undirected. So then pushback of your A and C. Okay, that's for sure. And now, remember I said we are going to use brute force. So solve it. So solve from 1 to n. Okay, and I think we are going to have answer. Okay, start from 0 and then see out your answer. Okay, so the thing is how we are going to implement this, right? Void of your solve. So then this is from and int of your 2, right? From 1 to n. Okay. Actually, the answer we have to make a very super big number first. Okay. So I think I'm going to make a constant ln of your inf equals 1e18. Okay. So initially it's 1e18. Why? We are going to minimize it. Minimize the answer. Okay. And then start from, so now remember I said brute force. Brute force means we still need to use so using some remember q, right? I'm going to use set, okay, for q. Using set for q. So which means we have to include set, okay, and I think we are going to use tuple, okay. And let's see. Before we do the things, right? We have to define something. What I'm going to do is, you know what? Remember, see here. This is, I just use this as level. These are just the levels. Okay. So level means what? Means, for one, I have level 3, I have level 6, which means I'm going to define I'm going to define to make light to save the I'm going to use a map. What? Because you cannot just use distance, okay? You cannot use long distance of mx. It doesn't work, okay? This one won't work. You have to you have to use unordered set, unordered map, okay? Int of your long. What's the meaning of that? Means for level. What is the cost? What is the cost? Okay. So you're not a multi-set. So unordered, you have to use unordered map. This is not a multi-map. So unordered map, you have to include separately. Okay, so this is going to for this distance, I'm going to use a map. So I don't know because I don't know the level yet. So I'm going to use a map. Okay, and another thing is yeah. So let's just try it. So remember the distance, okay? And initially it's from and zero. Certainly, I'm starting from zero, level zero to zero, okay? And remember we need a set, right? So this set, be careful, okay? Be very careful because I'm going to define a tuple. Did I put a, yeah, I put a tuple here. So I'm going to define a tuple. So type def, okay? And so this is a tuple, okay? Remember long, int, 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 y. So this is the cost, the total distance. I mean the total cost. I cannot use C because next one is C. C is the level and from to. This is going to save. I try to save as many information as possible when I push, when I do it, okay? So once we have this T4 level, then we can use a set of T4 level, T4i. So this is your Q, okay? Similar to the Dijkstra algorithm, okay? Although this is not a Dijkstra algorithm. So this is the meaning is this is a total cost, this is a level, this is from, this is to, from which node to which node. Once you have this, then you can just set dot insert. Initially so we are zero, right? And chili level, the level is still zero from minus one. Why? I'm from nowhere, so then zero. Okay, this is from node zero. Sorry, this is from, okay. From, so I'm coming from nowhere, okay. I'm to this place. That is initialized, right? So init, the the set. Okay, so then other than that, then what you need is just use while loop, right? While so your set is not empty, right? Similar to the Dijkstra. So similar to Dijkstra, but this is not Dijkstra. Why? Because Dijkstra is shortest, but my set is I'm I'm the D is not necessarily the right one. Okay, so then what you can do is out of it equals st dot begin. Okay, and then int of your p equals it dot. Sorry, this one is a tuple. It is a tuple. So tuple means you need to use get. Okay, get p. P is a parent. So parent is 2. Okay, and the u is get 3 of your it, and your level get 1 of your it. So just and this one is long long. Long long is d equals get 0 of your it. I think you should understand this. It's just this is d and this is c, right? And this is your parent. This is your current node. Okay, so once you have this, and then certainly you have to erase it from the queue, right? From the set, erase it, and then if your d is greater than, remember the distance, right? If your erase is greater than distance of u and c, remember c is the level. When you get it, it must be already in in this distance, okay? So don't worry if it should be there. If it's then you should continue. So skip it, right? Garbage. So UC is garbage. Why? Because I already get uh I because I already get a better one, right? A better one. It's garbage. So then if it's not garbage, then you just out of your next of your adjacency of your U, right? Adjacency of your U, get the neighbors, and then enter V equals next dot first, okay? And this is I'm just doing C2 next dot second. Remember this is a level, right? And certainly if your V equals P, continue. Why? No, uh, never go back, right? Because it doesn't go back. It want help, right? So don't, if your neighbor is your parent, should continue, right? Okay. Other than that, then you calculate the d2, right? What is your the d2 is your distance of your u and c plus. Remember now, remember this is your u. Suppose this is your u. Okay, so you already have, and this is c is this one, right? So you have to, if you want to go to, it's for the v, right? V. Suppose this is v, then you need this. This is c2, right? So you have to add up the difference. So that is ADS, right? C minus C2. That is your new distance. So once, and then certainly if your V equals as 2, I think this is, be careful. If your V if your V equals 2, don't return okay, because this is not Dijkstra. Dijkstra, if V equals 2, you can stop. You cannot stop. You just update your answer. So minimize your answer. So this is your minimum of answer and your D2. You still need to continue. Okay? Because not Dijkstra. Dijkstra you can stop, but not Dijkstra. You have to try others. Okay, so I'm not going to, because I also tested this algorithm for a long time. So I'm just to tell you the correct answer is after here. So still here next, still inside next. As I said, not really the brute force. You have to optimize. So do some optimization here. Optimization here. What optimization? So what you need is if your distance of v, remember the distance of v is distance v is here, v and your c. So certainly you need to count of c2, because if c2 doesn't exist, means this one is not. So this one is not tackled yet. If it's not, if it's 0, means not found yet. Or if your d2 is less than, your d2 is less than distance of v of your c2. This means the better one. This is a better one, right? Is a better one. A new one or better one, or better one, right? Okay. Don't insert yet. Don't insert to the set yet, because if you do it, you will get TLE. So you have to do some analysis here. I'm going to do see analysis here. So keep in mind, remember this is your U, this is your V, this is your C2, okay? And you already have a distance of U and C2, right? You already have it, okay? Already have it. Now this is, see here, this is you have a C here, right? And what you need is is, be careful here, okay? The, you need a, you need a, you need to check. Uh, sorry, this is your V, okay? And this is your U. Okay, U to V is C. And V, so, sorry guys, I was wrong. So this is use neighbor, okay? So this is C2, and this is V. And you already have, remember this is popped from the set. You already have U and C, right? And remember, so this one is, you already have a distance of V and C2, right? Okay, which means you have to check, does it worth it? Does it worth it? So because think about this in this case. So you can do the analysis later. Okay. So suppose, so if you have already have a two and three, right? And now you, this is already, you have it, the C and the C, and this is your V, and this is C2, and now you have a five and three. This is no use, right? Everybody, right? This is no use because same level. I I already I already I already have a minimum total distance here. If you have a five, you have to throw it away. So the idea is this one minus this one, the level. This is the distance. The difference of the distance should be less than the distance of this, right? The distance of this. Even this is 4, it is still no good. Okay, which means is this one minus this one. If should be this, the distance should be less than the difference of these two. So this is your new C and C2. Okay, this is your D and your D2. Okay, so you need to make sure. This is going to filter a lot of garbage. Okay, so which means what you need to do is you are going to check is valid equals true. Okay, and for for each out of your x, you need to check all distance, all levels. So if your x dot second is less than d2, and certainly you are new, so this must be less than this. Otherwise, if it's greater than d2, then uh, certainly your d2 is valid, and your d2 minus x dot first is greater than abs c2 minus x dot second. Sorry, this is second. Second is the level. So C2 second is the level. Okay. Sorry, this is first. So first is the level, okay, level, and the second is the value. First is the key. Okay, so then this is not valid. This is not valid. Okay, you break it. So and then after this loop, then if it only if it's valid, only if it's valid, then update your distance, and then insert into your set. Okay, so in this way, then let's see. So I'm going to copy and test it. Okay, so the sample works, and I submit. Control A, Control C, Control V. So I think the trick one is this one. Okay, this is the trick one. It's just it can filter out a lot of garbage. Okay, so we got a TLE. Something is not very right. Oh, so should be this. Okay, sorry guys. This is very important. Even it's equal, still it's not valid. So I think let's just resubmit. So modify this. Even it's equal, still not valid. Why is that? Because equal means no better, right? It's no better. So this filter a lot of garbage. So this problem, so in this way, brute force works. Okay, brute force works in this way. Certainly, this is not the right way. This is not the right way. Although we see we passed, right? We passed. Now let's talk about the right way. Okay, so this is a brute force, although it works. Now let's talk about the right way. Right way is simple. Okay. You know what? So this problem actually this problem. So sorry guys. In the CCC senior, I didn't talk about it. If you know the so layered layered graph, then you know this is a simple problem. What? This is really simple problem. If you know what is layered graph, you know what? Actually, when you do this, this is still a Dijkstra's algorithm. Okay, Dijkstra's algorithm. What you need is you are going to spawn nodes. Okay, actually, this problem, the node itself, it doesn't matter. Okay, node itself doesn't matter. What you can do is spawn the node. For example, so this one is I'm going to spawn this node. I'm going to spawn two nodes. So 1, 3. Okay, and 1, 6. Everybody right? 1, 3, 1, 6. Okay, this is this node, and this node I'm going to spawn four. So 2, 3, and 2, 2, and 2, 1, and 2, 10. Okay, four nodes. I spawn this. This one I'm going to spawn 3, 6. Okay, 3, 3. Okay, two nodes. Oh, certainly. So sorry. It also has another node called 3, 2, right? And 3, 3. Okay, three edges, three nodes, four edges. So this is also three edges for 3, 4, and 1, 4, right? I think actually, sorry guys. Uh, sorry guys. Better to sort it. Okay, better to sort it. So this is this is 2, 1, and 2, 2, right? And 2, 3, and 2, 10. You know why I need to sort it? Sort it. Okay. So 2, 1, 2, 2, 2, 3, 2, 10. This one is 3, 3. Okay, 3, 6. Okay, and sorry guys, I think I made a I should move. Okay, otherwise I don't have enough space, so I should move to here. Okay, so then this one, right? So this is 4, 1, and 4, 3, and 4, 7. Okay, 3, right? This one has 5, 7, 5, 10, right? Okay, for each node, how many edges spawn how many nodes? So three edges. Oh, I think I need to add one more edge, one more node here, 3, 2, right? Okay, so this one has 4, this one has 3, this one has 2. How many totally? How many edges? You have 1, 2, 3, 4, 5, 6, 7 edges. You will have 14 new nodes, right? So double the edges. Okay. So how many new nodes? You have 14. 7 edges, you have 14. Everybody, you can do that, right? And you know what? Now magic happens. Magic happens. Why? So what you can do is do this. See, this one is 3, right? From here to here, it's 3. This one is 1. This one is 1. This one is 7, okay? And this one is 1. This one is 3. This one is 2, right? This one is 4. What is this number? It's this number minus this number. We sorted it. It's always either 0, non-negative, right? And this is 3. Okay? You can do that, right? So this is edge, edge. And now what? Next thing is, see, from 1 to 2, right? From 1 to 2. This, 0, right? From here to here, no cost, 0. Okay? And I think I was wrong. Sorry, guys. So this one this 1 3 is 2 3. Sorry, this is 0. This one is 6. Okay, so this is 0. And 3 to 4. 3 to 4 is connected by 3. This is 0. And 2 and 3. 2 and 3 connected by 2, right? So which means this is 0. And this is 1. So that means this is 0. Okay? And 10. So this is 0, okay? 7. So this is 0. You know what? This is a new graph, right? Okay? So all the old ones are zeros. And make sure you connect this with this, not this, okay? Connect this with this. Same level, same level, connected with 0. And you know what? Keep in mind. So I'm going to use another color here. See, this is the end. This is the target, right? T, target. You want to reach here, and you are going to make a 0 0. Okay, and then what? Then just connect, right? Connect this one. Certainly, this is 3, right? This is 6. Okay, everybody understand? This is a graph, and then dichastra. Starting from here, you see you already have a new graph, right? Okay, so the new graph, so you can just use the standard, right? Standard diagram, diagram from here to here. Whenever you reach here, you stop. Everybody understand this? Everybody, do you understand this? The idea is spawn the nodes. Spawn the nodes, and then connect. So the old one using 0, because from here to here you don't have to cast anything, but from here to here you have to cast 3. Okay, the trick is sorted. Okay, why? Because from 1 to 10 you add up this, right? It is 9. From 1 to 3 add up, right? That's the reason why you connected with sorted. So in this way you can use standard dichastra. So the idea is first step is generate a new graph. Generate a new graph. Second one is just to call the standard dichastra. Get the total. The minimum is the answer. Okay, everybody understand it? Once you understand it, let's sorry, okay, very late, but let's finish the coding, okay? Because maybe some students still have trouble how to generate a new graph, right? So let's do it. So now I'm going to use CCC 25 S4. This is called layered graph. Okay. So layered. Okay. So then that's just the implemented code. So the actually, you know what? I'm going to split. So open this. I'm going to make use of this. So split to the right. Okay. So then CPP X, I'm still using X, okay? And remember, we are going to have still need a vector because we need a adjacency list. And remember, we need to sort it. We need an algorithm. And this time, now priority queue is enough. Okay, priority queue is enough. Okay, so then int of, I think these are the same. I'm going to copy paste this. Copy paste this. This is the same. And adjacency list. Uh, I don't think we need adjacency list anymore. Okay. Be careful, right? So what we need is the vector of your PII. This is neighbors. This is going to save the cast and node ID for neighbors, okay, of original node, okay? The cast and node ID, okay? So this node ID is a new node ID, original node and new node ID and cast. Once we have this, and then remember vector of your PI adjacency list. Be careful. This time you have to double it. You have to double, double the size. Why? I told you your node is doubled of your M, right? So your M, actually this is M, okay? Because the maximum is still 2E5, okay? So then after that, then sequential number, this is going to generate, use as a sequential number to generate new node ID, okay? Okay, so then next is type. So we already have type. So now after that, I think others are the same. Distance of n max multiplied 2. We need distance, and let's just certainly the constant of long we still need it. LF the inf equals 1e18. We still need it. Now let's try to do it. So what you need is read the C in n and m, n and m, and then for int of I equals 1, I less than or equal to m I plus plus. Be careful. So I is the edge ID. Edge ID is very important, okay? So starting from 1. And then, so read this A, B, and C, okay? So then C in A, C in B, C in C. Oh, sorry, in C in A, B, C. And then remember using sequential number for new node, right? New node. New node. So A and C, right? Remember C is your C is so A and C, right? You need two new nodes, okay? New node A and C and new node B and C, right? Right? Okay, so that means so sequential number for this one, sequential number plus one for this one. So that's what we want. So the adjacency, remember the new node is sequential number. Okay, push back. Okay, see here, what did you push back? Sequential number, push back. Push back the you know what? I don't need this number at all. This is the old node number. I don't need this. I just need this, right? Remember, I told you this becomes 0, right? Becomes 0. So which means you just, this is 0, okay? And C, 0 and so 0, pushback, 0 and sequential number plus 1. Why? This is sequential number plus 1. This is sequential number, right? They are connected with 0. Okay? Remember, do the same thing, right? Sequential number plus 1 dot pushback 0 and sequential number. Okay? So we are done with these green ones, right? Okay. And certainly, certainly, yes. So we are right. And also, what we need is we also need a boolean. Boolean. We need to know where's the target, right? So uh, down, is it down? Means mx multiply 2. Certainly you can save with two values, but to save with a vector, but I'm going to use this so that I don't need to. So that means I don't a vector is not enough. So that means if your a equals n, right? This is an end, right? If a equals n, it means down. Sequential number equals 2. Okay? If b equals n, your down of your sequential plus 1 is 2, right? Okay? So I'm save a lot of time just using array for the sequential number. Because when we use die construct, we need to know when we are done or not. Okay, and then what you need is also remember we need neighbors to here neighbors. So the neighbors that means we need this neighbors of your A. Remember A is the original node, neighbor of the original node, because we need to sort it and generate a new node again. Generate some it's not generate. We need to sort it, right? So this one is pushback. Pushback what? We sort it according to C, right? According to the level and sequential number, right? Okay. Actually, it's not neighbor. It is spawned. Spawned, right? A spawned. This A spawned, A spawned 2, A spawned 3. It's spawned. Okay. So then once we have this and do the same thing, MBS of B, right? Push back. Okay. And then C and sequential number plus 1, right? Okay. So that's it. Uh, yeah, so that's it. And certainly don't forget to increase by 2, right? Is that right, everybody? Okay, so let's try it. Let's continue. So I hope it's right. Once we done that, I think this problem also I don't know. If you check the original, check the problem. This one it says n could be 1. I don't know. So if n equals 1, which means I don't know. So if n equals 1, right? So that just C out 0, right? I don't know. Return 0. So in that case, then I don't worry about if it's 1 or not. And then after that, remember you need to here is the you need to sort the spawned node, right? So sort the spawned node, which means for int of I equals 1, I less than n, right? Less than or equal to n I plus plus. Remember, everything is in your neighbor. NB equals neighbors of your I. Everything in your neighbor, you need to sort it, right? Remember, I already put C first. So sort it, neighbor dot end. Okay, sort it. Okay, and once you sort it, then for int of j equals 1, j less than nb dot size and j plus plus. Okay, and then pi p1 equals neighbor of j minus 1 and p2 equals neighbor of j. Remember this is a pair, right? A pair. And now you are going to generate the edge here, right? Generate this edge, these edges. So let's generate the edges. So the edge means adjacency. Remember P1 dot second is that this is a new node number, right? Second is a new node number, and you are going to push back, right? Push back is P2 dot first minus P1 dot first. Remember this is C difference here. This difference and this, right? C is a difference. And certainly you need also need a P2 dot second. This is another the new node, right? Okay, do the same thing of P2 dot second dot pushback, and P2 dot first, still P2 dot first because sorted. So this P2 is must be greater than or equal to this first. So P1 dot first and P1 dot second. Okay, that's it. Okay, so once you're done, we are done with the new graph. So we are done with the new graph. So next thing is the next certainly you also need to add you add need these two edges. Why? You cannot just add this edge because it's possible you should you if you add one edge, I think it's not enough, okay? Because you know, you don't want to go back and forth. So you better to add both, okay? So that means you are going to add additional edge. So 4 out of your x of your neighbors of your one, right? Okay, so then 8j of your 0. You are going to start from 0. So push back. So that's the reason why I node number I'm starting from 1. Okay, so 0 is going to be the the faked one. So this is x first, and the x second, right? X dot second. Second is a new node. First is a level. Okay, so once we're done, now we are ready using standard Dijkstra. Okay, so which means the field, I think we have distance, right? We define the distance. So field the distance, okay, distance and plus 2 m maximum with the maximum, with the inf, right? Infinity. And then priority queue, okay? And this is P. Be careful, right? We have to use long long. So we have to use long long. So which means we have to define another type def, pale, long. I'm going to use PL. So in here, this has to be PL. So long. Okay, and then I'm going to use remember the vector of PL, and we are going to use greater. Why? We want the smallest first, right? Okay, priority Q. So this is mean. So minimum priority PQ. Okay, mean PQ means mean first. Okay, so then distance of 0 equals 0. This is standard, right? And Q dot push 0. Remember, first node is 0. And then while, okay, Q is not empty. And out of X equals Q dot top and Q dot pop. This is Dijkstra, okay, standard Dijkstra. D equals X dot first, okay? And U equals X dot second. And then if it's down of your U, I think you are should use this. I think you are done, right? So this is now you can end return 0. Why? Because of the Dijkstra. Dijkstra, whenever you find it, you return. This is the shortest. Okay, and otherwise, why I get this? So otherwise, so if your D is greater than distance of your U, this is garbage, right? Garbage. Because Dijkstra, you didn't erase things. It could have a lot of dark garbage. And therefore, out of your next of hj of your U, and then if, so get the W equals next dot first, okay? And inter V equals next dot second. Okay, so if your distance of your V is greater than distance of your U plus W, right? Then distance of V, update your distance. And then put it in Q. And the distance of V and V, right? That's it. So standard Dijkstra, okay? Standard Dijkstra. I think that's it. I think that's it. So this is the code, and let's try it. Let's try it. Open the Visual Studio Code, and then so certainly we test this. What is going on? Okay, I'm going to copy and paste. Do we get 9? We get 9. Okay, so then let's submit. Okay, see, we got 17. So this is much better than before, right? You know what? I know this is very late, okay, more than 9 o'clock. Do you want me to continue or what? You know what? This is not the best answer. This is the right answer, right algorithm, not the best. Why? Do you know why? Why do you know why this is not the best? So the problem is these two are the same, right? These are the same. So then why? So actually you can put them same node, right? See, these are same node. So which means you can improve your algorithm. You know what? I told you the node number doesn't matter. Okay, only this edge number matters. Only this matters. Only this matters. Only this matters. Only this matters. Guys, do you want me to write the best algorithm, or you think this is enough? Guys, I want some feedback. I told you, certainly, this works, right? It's good. But I can tell you this is not the best. The best is you can use the edge. You don't need the node, okay? You can use the edge. Certainly, maybe let's quickly rewrite the code, okay? Rewrite the code. So actually we don't need the sequential number things. We just use the edge, okay? Use the edge, right? Edge is enough. We just use the edge number. See here we didn't use the edge number. We can use the edge number, right? See here, these two same edge, same. So that means same node, same edge, same node, same edge, same node, right? So we can use edge. Okay, so let me quickly write the code. Okay, we can improve this code. So I'm going to create a new one. So this is CCC 24 S4. This is so just to use this is what is the LG layered graph. So we can use we use layered graph CPP2. Okay. So we are going to use edge. Not we actually don't need the some node. Okay. So we can use edge. Okay, as node number as new node number. We don't need that. We don't need we don't have to create a new node number, okay? Which means this is the same. I'm going to copy paste, okay? And I think so these are the same, okay? And I don't need the neighbor at all. I don't need the adjacent. So actually I can use vector of PII as the first adjacency, okay? And the second adjacency. Okay, I'm going to modify the first adjacency to the second adjacency. This is the old adjacency. This is new adjacency. And remember, if we share it, we shrink the node number. Node number is the edge number, right? So we don't have to double it. No need to double. Okay, and certainly we still need down mx. Okay, and so I think all others are same. Okay, so we have to copy paste. We have to copy paste. We have to copy paste this, but we don't need a double. Okay, so mx actually mx is enough. Okay, so I think that's it. And then what we can do is, so in here I'm going to copy this. Control C. This is same. Copy here. Okay, and so so then for int of I equals 1, I less than or equal to mi plus plus. Remember this is edge ID using edge ID as new node ID. Okay, so that's it. See here, I'm just using the edge IDs. These two nodes are the same, right? So once we have this, now, so int of your A and B and C, okay, and then C in A, C in B, C in C, and then AJ of A dot pushback. This is for sure, no problem. C and I, Because this ADJ is an old ADJ, and the ADJ of B push back. So this is A of so this is sorry, this is C of still C of I. Okay, because I is a new node number, and C is the cost. And also another thing is if A equals N or B equals N, done. So this edge is the end edge, right? Okay. So once we have this, now, so for we are going to convert the AJ to the AJ2. So for int of I equals 1, I less than equals n I plus plus, and then sort. Certainly you have to sort the AJ, okay? I dot begin, AJ I dot end. Sort it, still need to sort it, and then for int of j equals 1, j less than. I think this is same. This is same. So j less than the AJ of your I dot size and j plus plus, and then int of w1 equals AJ of your j I minus 1. Sorry, I j minus 1 dot first, and u equals AJ of your I the previous second, and the int of your w2 equals AJ of I and j first, and v equals AJ of I and j minus 1. Sorry, j dot second, and then AJ of 2. Remember u. Remember this u is a new node ID, okay? So then push back. Push back w2 minus w1, right? W1, and this is v. And AJ of your v push back w2 minus w1 and u. Okay? Certainly it should be a pair. Okay? Then and certainly you still need this x, right? So which means 4 out of x of your adjacency of your 1. Okay, adj2 dot 0 dot pushback. Okay, x dot first, x dot second. Same thing, right? Okay, once you are done with this, I think all others are the same. Okay, I think I can just copy paste. Sorry guys, I'm going to copy paste everything. Okay, copy paste everything. So fill it, copy paste everything. Control C. This is standard diagram. Certainly you have to modify a little bit. See here, this is not so this is not doubled. Okay, and same, but this is adjacency 2. Okay, ADJ2, not ADJ. Okay, so that's it. That's it. So this is the code. So certainly this is the best. Okay, and then certainly we can test it to see if it works. So control C, copy and paste 9, and then submit. So control A, control C, control V, submit. Right? 11. Wow, it's much better, right? Certainly, you guys, I think if you know this, spawn the nodes. That's enough for this for the CCC senior. Okay. Sorry, guys, very late. I'm going to stop. Okay.